When we think of the stomach, most of us just picture a simple bag that holds our food, right? But it is so much more than that. It's this masterfully designed piece of biological architecture, a dynamic chemical plant, and a super powerful mechanical mixer all rolled into one. So go ahead and grab your hard hat. Let's begin our architectural tour of one of the body's most fascinating and hardworking structures. And in any great design, location is everything. So before we unroll the blueprints, let's just pinpoint where the stomach actually lives and get a feel for its role as the command center of our digestive neighborhood. And there it is, tucked right into the upper abdomen. The stomach is nestled comfortably between the liver on its right and the spleen on its left. Now, its position isn't random at all. It's perfectly placed to be the central stop on our food's long digestive journey. And you can't miss its shape. That classic J shape isn't just for looks. It's a huge part of its function. It allows it to be this dilated, expandable part of the digestive tract, always ready to accept a meal. But just how expandable are we talking? Well, the average adult stomach can hold about 1.5 to 2 liters. To put that in perspective, that's roughly the same as a large soda bottle. That incredible capacity is a really clever design feature, probably a holdover from our feast and famine evolutionary past. All right, so now that we know where it is and its basic shape, let's pull out the blueprints. It's time to take a much closer look at the specific layout and the different zones that make up this incredible structure. This diagram gives us a great bird's eye view. You can see the esophagus entering at the top and the stomach emptying out into the small intestine, the duodenum, right at the bottom. Okay, so let's explore each of these distinct regions one by one. So the stomach is basically divided into 4 main zones. First, food enters through the cardia, kind of like an entry hall. Next up is the fundus, that dome-shaped area at the top that often collects gas. In fact, you can sometimes spot it as a little shadow on an X-ray. The largest section is the body, which is the main mixing chamber. And finally, the pyloric part acts as a funnel, guiding food toward the exit. Every great building needs controlled entry and exit points, right? And the stomach has 2 absolutely crucial ones. The cardiac orifice is the indoor, where food comes in from the esophagus. The pyloric orifice is the outdoor, leading to the small intestine. And this exit is guarded by a really powerful muscle, the pyloric sphincter, which basically acts like a bouncer, deciding exactly when the stomach's contents are ready to move on. So, we've seen the overall layout. Now let's talk about the construction materials. The stomach wall itself is just a masterclass in biological engineering. It's brilliantly designed for both brute force and some really delicate chemistry. Okay, here's a key design feature that really sets the stomach apart. It is the only organ in the entire digestive system with 3 layers of muscle. Everything else just has 2. And that third layer? Well, it exists for a very important reason. And here they are. You've got the inner oblique, the middle circular, and the outer longitudinal layers. Now, these muscles don't just push food along. They twist, they squeeze, and they churn it in every single direction. This powerful 3-dimensional motion, which we call peristalsis, mechanically breaks down food and mixes it thoroughly with digestive juices. It's literally a biological blend. So, if the muscle is the brawn of the operation, then the stomach lining, the mucosa, that's the brains. This microscopic view reveals this incredible landscape of tiny pits and glands, and this is where the real chemical magic happens. These aren't just simple folds, they are the doorways to the stomach's own chemical factories. And inside those factories are these highly specialized cells, each with a very specific job. You have parietal cells pumping out hydrochloric acid to kill off microbes. You have chief cells releasing pepsinogen, which kicks off protein digestion. And then you have G cells, which produce the hormone gastrin. That's the messenger that tells the parietal cells, hey, make more acid. It's this complex and just beautifully regulated system. Of course, no building can function without its utilities. The stomach needs a constant supply of power and a sophisticated control system to manage everything it does. And that means we need to talk about blood, nerves, and lymphatics. When it comes to power, the stomach's design is a total model of efficiency. Get this, its entire blood supply, all the oxygen and nutrients it needs for its incredibly heavy work, stems from a single source, the celiac trunk. That centralized system ensures a really high-yield, reliable power grid. Here, you can see those 2 systems side by side. It's pretty cool. On the left, you've got that dense network of arteries. That's the plumbing that delivers the fuel.
And on the right, you have the nerve pathways, especially the big one, the vagus nerve. This is the electrical wiring that carries the commands, telling the stomach when to get to work.
And this control system has both an accelerator and a brake. The parasympathetic system, through that vagus nerve, is the go signal. It ramps up acid secretion and muscle churning right when you eat. The sympathetic system, on the other hand, is the slow down signal. It often kicks in during stress, restricting blood flow and activity. You know, a tour of any great piece of architecture isn't really complete without understanding its potential vulnerabilities. So let's briefly look at what happens when this incredible design runs into some problems. A pretty common design failure is peptic ulcer disease. This is what happens when that protective mucosa layer we just saw gets breached, allowing that powerful acid to literally burn a sore directly into the stomach wall. It's a painful reminder of just how critical that inner lining is for self-preservation. Remember that muscular gate at the exit, the pyloric sphincter? Well, in a condition called pyloric stenosis, which is common in infants, that muscle becomes too thick and just won't open properly. Food has nowhere to go but back up, which is why it's such a well-known cause of projectile vomiting. When you really step back and look at it, the stomach is this organ of incredible contrast. It's engineered to be a hostile, corrosive environment, which is perfect for destroying invaders and breaking down food, while at the exact same time protecting itself from that very same power. This delicate balance, that is the true genius of its architecture. We've just toured an absolutely incredible structure that works tirelessly for you 24/7. So the final question isn't for me, it's for you. Knowing how it's designed and all that it does, what's one choice you can make today to support its powerful, lifelong work?